let's get started. I would like to introduce Kaizen's own Regional Manager, Kevin Buckner.
Thank you, Sherry. I appreciate that. Well, as Sherry said, my name is Kevin Buckner. I am the Southwest Regional Sales Manager for Kaizen. And welcome to the game of concentration. And yes, it can be a game. I decided to put this presentation together just to give you the basic guidelines of, is my bath concentration in check? And if it is, will I get clean product? So, is my bath concentration in check? I know this sounds funny, but the first thing you have to do is check it. You have to ask yourself a question. Are you using a hydrophilic or a hydrophobic chemistry? Hydrophobic chemistries tend to split, very similar to oil and water as you would see them in your glass or on a salad. Hydrophilic chemistries tend to blend. The chemistry and the water go together to make one, as you would put coffee into your creamer into your coffee. Now I ask, how do I test concentration? Well, first thing you should do is check with your supplier. The second test, the next thing I would look to is actual testing itself. We have split testing, which is for hydrophobic chemistries. We have refractive index testing, which is for hydrophilic chemistries. And we have titration. That works for both types of chemistries. The split test for hydrophobic chemistries, simply you need a sample vessel. You need a fresh sample. You need a reagent. You need a conversion chart. And you need about 8 to 10 minutes. You'll first take your sample vessel and put some reagent. As you can see that we have red reagent. That separates our chemistry from our water and makes it easy to see. You'll then add a fresh sample of your wash chemistry to the sampling vessel itself. You put a cork over the end of the testing, the sampling vessel. You flip it upside down a few times, remove the cork, and let it sit, typically for about 8 to 10 minutes. From that point, you can calculate the amount of milliliters of solvent that you have on top of the water. You'll then use a conversion chart similar to the one you see that tells you the milliliter volume equals the concentration you're running inside your tank. The next test that we'll cover is refractive index. This is for hydrophilic style chemistries. You'll need a refractometer, you'll need a fresh sample, you'll need a Brix chart, and about 1 to 2 minutes of your time. You'll take your refractometer. There are two types, which is an electronic style or an optical style. You'll take a fresh sample of your wash bath. You'll put a drop either into the container on the right-hand side, the eye, if you will, and then you'll put a drop onto the glass slide if you're using the optic version, and you'll get a Brix chart number, a scale number, if you will. That works with reflection of light through a prism. With that Brix number, and please, please, please don't confuse a Brix number with actual concentration. The Brix number is simply a reference point that we will then use our chart to tell you what concentration you're running versus your Brix number that you have. And then the third method that we use is titration. This works for either chemistry. You need a beaker, another fresh sample, some reagent solutions, indexing charts, and then 8 to 10 minutes of your time. Taking a fresh sample, adding some type of reagents to the material set, and then dropping, if you will, drops into the sample that you've taken and wait for a color change to happen. You then count the number of drops. Once you know the number of drops, that will correlate in an indexing chart to tell you what concentration you're actually running. So now you have a number. Let's call that number 15%. Well, to be honest, you're one step ahead of the game. You'll be surprised, amazed at how many customers don't have a process definition in place. They don't know how to define what concentration they have or need, let alone what they're running. But don't worry, we're here to help you with that. All you need to know is to justify or to quantify that the concentration that you have is working for you. But how do you do that? Well, Did you run trials before you implemented this process? What do those results tell you? And what, as Justin Timberlake's hair will tell you, has changed? Changes can be simple things. Changes can be, on the left side, we ran one board in our testing protocol, and now we run a lot more product. This typically happens when a contract manufacturer runs a trial on 15 boards, but their actual production level is 1,500 boards, 15,000 boards that are going through the wash process. This will have an impact. Other changes, if you're running more product, I advise that you check your concentration more often. Look for signs of loading with flux and other residues. Now, if you're interested in bath loading effect, make sure you look on our website for our very own Scott Kane's presentation of to dump or not to dump your wash bath. That is the question. Running more product is a typical result of adding a chemistry into a wash process or onto a factory floor. Those boards just seem to look better, and that's a reflection of you and your company. We often see boards come into a facility and a CM has been told they have to clean the no cleans. We work with that CM, we get them cleaning those no cleans, and they see that product as it comes out of that washer and say, if this works that well for that product, I'm going to clean those as well. And don't forget, it lowers your liability as well. Changes such as running a neutral product. Well, let's think about that. If you start at a neutral pH, what happens when you add base-like flux acids? Well, the pH has to drop, even with buffers that we put in the material set to try and stop that from happening. If the pH does drop, you'll find you have to raise the concentration to counter this effect. If you start your testing showed 15% when you started your process, and you run it for a week or so, and you start to see cleaning deficiencies, check to see what your actual concentration is. With neutrals, you typically have to raise that to closer to 25% to get the same results with a little bit of loading. Now, that's not cost effective. Cleaning efficacy, your starting point was 15%. Once you started cleaning those acids off, you see that concentration will drop because of soil loading. After 1 week, you may be down as low as 7%. So what people find they have to do is boost that back up, if you will, to 25% to continue to get the same results that they got when they started at 15%. Other things, did you set up a simple log for testing what your wash water is? I always suggest that at the start. This is just a simple example of something that we would say, use this and generate some type of program. I always suggest that you assign the same person to testing concentration on a daily basis, 1 time a day for the first week. When starting up a new process, it is critical to maintain and keep concentration in control. Then you can move it to twice a week when the process is in hand, when you fully understand exactly what's going on. A quick concentration test can stop many issues before they even start. Some other points to ponder that we have. Aqueous cleaning fluids that are designed to operate at low concentrations can reach a critical soil loading level at a very fast rate. The key is to find the correct concentration to clean and not to soil load. Some of the other stuff, keep in mind, cleaning materials are built with solvents for dissolution, reactivity agents for saponification, wetting agents for surface tension reduction, and minor other ingredients for foam control and inhibition. There is a lot going on here. The electronic wash processes are also rarely static, but they're very dynamic. Most of the wash processes losses will occur through exhaust evacuation and drag out from the wash over to the rinse section. As wash chemistry is lost from the system, some of the soil is also lost. As long as the losses of wash fluid and the addition of new fluid, new wash chemistry are maintained, the wash bath is kept under a critical soil loading level, and the wash bath life can be extended. Simply stated, if you control your wash water, that's money in your pocket. So really, what's my point? Well, my point is keep an eye on that wash concentration and check the critical soil levels. All right, that's all I have for this Tech to Tech. Sherry?
Thanks, Kevin. If you would like to discuss this topic further, please contact your local Kaizen regional manager or send an email to tech@kaizen.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.